All right, let's get some vocab done so you understand what I'm talking about when I speak of these things. We're just going to draw arrows to these items. So the vertex of a pyramid, because we're talking about pyramids today, is the point where all of those triangles meet together. That's the vertex of the pyramid. Lateral face are all of these triangles. Lateral edge are all of the lines that meet up together at the vertex. The base is whatever shape is on the bottom, the one that we name it for. So it could be a hexagon, it could be a triangle, it could be a square. Base edge are these lines that go around the base. And then I left the last two for the end on purpose. Okay, so the height and the slant height. There's a big difference between the two. The height is used when we are talking about the volume of the pyramid, which we're not doing right now. We'll do that later. Okay, so this right here is the height of the pyramid. It's how tall the pyramid is. Okay, but we're looking at the surface area. So we want the height of the triangles because we're going to be finding the height of those so we can get 1/2 base times height when we do the area formula. Okay, so you're going to need to know the difference between those two. We don't use the height that goes inside the pyramid because that would find the volume inside the pyramid. We're not doing that yet. We're looking at the surface area, so we want the height that's on the surface. Okay? Questions? Okay, how do we find the surface area of any pyramid? What are we going to be adding together? Whatever the base is, plus what? All the triangles. Now there could be 6 triangles, there could be 8 triangles, there could be 3 triangles, however many there are around the outside. So if we had a square pyramid, it would look like this if we flattened it out, okay, which is called a net. We talked about that in the first section. What would these be? These green lines. Slant heights. That's not the height. These are the heights that we want to use to find the surface area, because that will give us the area of the triangles. Now on pyramids, we're always going to find just the area of one triangle and then multiply it by how many there are. So really it's just the area of the base, area of one triangle, and then times that triangle by how many there are. So let's take a look at this one. Find the surface area of a pyramid with a hexagonal base, and each base edge is 60 meters long. It has a slant height of 85 meters. I'm going to draw the net of this. Question?
It's 35 meters on our...
Okay, change it if it's written differently on your notes. We're going to do a slant height of 85. All right, so looking at this, we have a hexagon and then we have all these triangles. So here they gave us the slant height of 85. And each base edge is 60. So all of these are 60. All right, let's do the triangles first. So we'll label it, and we're going to show 3 lines of work. What's the formula for triangles? What are the base and the height of each triangle? 60 for the base, and the height on each one is 85. What's the area of one triangle? Say that again?
2,550.
What do we have to multiply this by? There are 6 of them. What's that number?
15,300.
So the lateral area, just to remind you, the lateral area of any 3D figure is everything but the bases. Okay, so in this case with a pyramid, it's just what all of the triangles equal. But we want the total surface area, so we also need the base, or the hexagon. What's our formula for hexagons, pentagons, octagons?
No, just kidding. 1/2 AP.
1/2 AP, good. Okay, so we'll go back to our drawing here. We'll draw the apothem. We're going to need that. That's the little a in the formula. What does P stand for in the perimeter? I just said it. It stands for the perimeter. Okay, so let's do the perimeter because we can easily find that. What would it be? 60 times 6. Our total perimeter is 360. Now we need to find the apothem, this x right here. How long is this? That's 30. How big is the angle? What do we do to find that? $360 divided by 12, because there's 12 triangles just like that black one that we could draw inside of there. So it cuts that into 12 equal triangles. We get 30 right here. So is that sine, cosine, or tangent? It is tangent, opposite over adjacent. Good. So we do tan the angle equals, what order will this go in? Has to go opposite over adjacent. We always multiply by the denominator. So now we have x tan 30 equals 30. Divide by tan 30. What's our apothem?
51.96.
All right, so that goes here. And we can find the area of the hexagon. What do we get? Do we have to times this by anything? No, there's only one hexagon. Okay, so we'll add this to our lateral area. What's our total surface area? How much?
26092.
And meters squared. Questions? That was a good refresher on how to find 1/2 AP formulas. We ready for the next one? All right, we have a pyramid over in Giza. It was built a long time ago. It has a height of 481, so let's draw this on the picture right here. Here's our height. 481 feet. The edge of the square base is 756. It's a square, so we can put it on both of them here. Find the lateral area to the nearest whole number. So what is the only thing we need to find? Which is what? The 4 triangles. Okay, so we're not going to find the area of the square on the bottom. We just have to find the triangles. So we have 1/2 base times height. And then we'll times this by 4 once we get this area. What's the base of the triangle? Do we know the height? No. Okay, so let's draw the slant height on the right-hand side over here. Okay, there's the slant height. We need that line right there. Any ideas on how we could find this red line?
Pythagorean.
How?
You draw a little line above.
Like right here? How long is that blue line?
Okay, so
We just cut this number 756 in half. Someone do that. How much is that?
378.
Perfect. Okay, so now we can do Pythagorean theorem. These are going to be large numbers, so you're going to have to help me out here. 481, 3, it's not 71, 370, yeah. All right, what are these two numbers? Help me out. Those of you with calculators. More than one person should be helping.
231,361.
Hold on. 231,000.
361.
Is that both of them or just this one?
Just
Okay. Somebody else, what's this one?
142,884.
Add them together.
374,240 or 45.
Now what? Square root. What do we get for the slant height? Okay, so we just found out this right here. Now we can find the area of one triangle. And then we'll times it by 4. What's the area of just one triangle? Just read the numbers.
231,305.76.
Okay. So we'll times that by 4. It's the lateral area of this pyramid. The part that you can see sticking out of the sand.
925,223.04.
Questions? Anyone get different numbers that was traveling along with us with the calculator? You got different numbers? For where?
It was 611.92.
What did you get?
611.75, but it's not really that big of a difference.
Well, but I wonder why it's different, because it shouldn't be if we're square rooting the same number. Double check. Is this number?
That's how it is on my notes when I did it.
I'll double check a few of these numbers.
What makes you so sure?
I got it.
This should be a 2.
Yeah.
That's why.
Okay, so then that changes just a little bit. It won't change our final answer very much, but
Not whatever did that.
we'll just go with our final answer.
Okay.
We'll say about. Okay? We'll consider it okay. We get the idea. Questions on that? You will have to do something like this for this chapter, homework, test, so be aware of cutting that number in half so that you can have that right triangle inside the pyramid. All right, last one. Find the total surface area of the square pyramid round to the nearest whole number at the end. Don't round to the nearest whole number until the very end. Okay, so I am going to give you a head start on this one. I'll get the formulas up here so that we can just fill the numbers in as we go. Okay, so I'll give you a minute head start, and I don't want you staring at me and waiting for me to do this in a minute. You're going to start the problem. We're going to have to begin this problem the same way we did the last problem. You're going to have to find the slant height.
Jack, you have your marker on white.
You have to start with Pythagorean theorem so you can find your slant height.
It's not like you're gonna do it. I was thinking
All right, so we've got that information. It's a square on the bottom. They call it a square pyramid. How long is each side on the square?
6.
Okay, how did you get that?
3 times 2.
Yeah, right here is 3, this orange dotted line. So if we take that all the way across, that would give us 6. So that means our square on the bottom has an area of 36. 6 is also the base of each of the 4 triangles. So what do we get for the area of the triangles?
22.848.
Do we have to multiply the 36 or the 22 by any numbers?
No, you add. It's 36.
Oh, yeah, yeah, 22 to 22.84.
How many are there?
There's 4 of them.
Okay, when you write your labels, it might be a good idea to write down how many there are so you don't forget to do that at the end to multiply. So we need to times this by 4 because there's 4 of them. So now what is that?
91.392.
Now we can add it to the 36, which is what? Rounded to the nearest whole number because now we're finally at the end.
127.39.
Okay, so if it's 127.39, what's
127.
nearest whole number is 127. No units, so we don't need units on the answer.
Doesn't have
Questions?